course, planets. The moon isn't the only thing up there that we know has craters on the surface. If anyone's seen any pictures of Mars, you would have seen there's lots and lots of craters on the surface. Now it's interesting, this particular crater here is called the Smiley. You can see the eyes and it's just a little smile. So we call that particular crater the Smiley. But for the same sort of mechanism, if you hit the surface of Mars hard enough with a big enough rock, it'll throw the material into space, and the gravity from the Earth won't bring it in, but the gravity from the Sun will attract it in, and as it comes in, if it gets close enough to the Earth's gravity, pull it off its course, it'll come and land on the surface of the Earth. This little piece of stone here, similar to the lunar one, this is actually a piece of the planet Mars though. So the same things happen. A large asteroid or something has hit the surface of Mars and thrown the material up into space, and eventually it might take millions of years, but it's come and it's landed on the Earth. Now of course, Apollo 11 went to the moon, but we haven't brought anything back from Mars. But we've set lots of landers, like Pathfinder, Phoenix, and a lot of others, and they've been to Mars and they've done the chemical analysis of what makes up the rocks on Mars. And they know that these little Martian meteorites have got the same type of rock. We don't have rocks like that on the Earth. We certainly don't have them where they found these. A lot of these were found in the Antarctic. So these rocks would have been just found on a plain of this ice. And there's a big burnt rock sitting there. And it's completely foreign to all the rocks in the Antarctic. But it's got exactly the same chemistry as the rocks up on Mars. So that's how we know it came from Mars, even though we haven't brought any back yet. So how common are the Martian meteorites? It's interesting, we only had 40 odd kilograms of moon meteorites, but we've got 94 kilograms of Martian meteorites. The main reason we've got so much is because the biggest ones weigh so much. Like the biggest of this type of Martian meteorite weighs 18 kilograms. So we've got some very large samples. That's why we've got more Martian meteorites than meteorites from the moon. And even though you would think we'd have more from the moon, it's just we've got smaller pieces of it. And they put it into three different categories. They come from three different parts of Mars, maybe from the highlands or the lowlands, the plains, stuff like that. And so they give each of the three types their own name to describe the type. And they call them SNCs or SNCs for short. The sugartites, narcotites and chasuchnites. The three different types of Martian meteorites that we've been able to find. But the Earth is not the only place that has meteorites. In 2005, when the Opportunity rover landed, the first thing they wanted to do, they could see the big shield over in the distance. And they thought, let's go over, we've just landed here, we'll go over and we'll check out the big shield. And as they got closer, they noticed there was a rock just over in the corner. So they have a little laser that they can point at something to measure the chemistry of it. So they shone their little laser at this rock, and it was like a mirror. And they knew they weren't shining at this, because this obviously looks like a mirror. They were shining at this rock, and it returned the same sort of colour as the sky. Which they thought was unusual. Was it a mirror or something like that? So they drove the rover around there. It would have taken a number of days because the rover moves really slowly, not to get this fast. It takes a long time to get anywhere. And they got around, and when they looked at it, they could see it was exactly the same sort of meteorite as Aussie. It was an iron meteorite. But they couldn't test it because they did some tests. They have another copy of all the rovers on Earth, so they can test them for various things. And they worked out that if they tried to sample this iron meteorite, they would destroy the sampling head. And it only just landed there. So they couldn't do any further tests, but they knew it would just be exactly like that. It's exactly the same type of meteorite, iron. And since then, the Spirit rover has found another 2 more meteorites. They also found meteorites on the Apollo missions. So they actually found rocks on the moon that weren't from the moon. So they found some of the pieces of the meteorites that created the craters on the moon for Apollo 11 and 15. But Mars and the moon are not the only objects either that have lots of craters on them. Mercury is also covered in craters. It looks very much like the moon. So by the same mechanism, if you hit the planet Mercury hard enough, maybe you'll get a little piece of the planet will land on the Earth. And this tiny little piece of stone here, very, very tiny, right? We believe that's a piece of the planet Mercury. The problem is we haven't been there, we haven't sent a rover, and it's only now that Messenger has just gone into orbit in the last week or two that they haven't. Actually, I think they're supposed to turn the cameras on about 2 or 3 days ago after finally went into orbit around Mercury. So they might be able to do better examination of the materials on the surface to determine if that is actually from Mercury. At the moment, we believe that is the type of rock that's on the surface of Mercury. Until we get more information, we don't know for sure. Now I mentioned all the asteroids out in the asteroid belt. They get hit at some time. There's a large one called Vesta. It's about 500 kilometres across. So it's 500 kilometres, 530 across, and it has an impact crater 460 kilometres in diameter. So it has a crater that is almost as big as the asteroid Vesta. So they know at some time it's been hit with something really big. And they found some samples of meteorites, and they believe that this one in particular has come from Vesta. So this little piece of stone, just looks like a piece of stone. They know this is actually from the asteroid Vesta. It's interesting, this particular one was found in a place called Tatooine. Anyone that knows Star Wars will have heard of Tatooine. So there is really a place that's in Tunisia. And this was actually found in Tatooine. Yeah, it's a real place. A lot of the movies, they get all these things from the name of real places because then they don't have to think of something else. So they know that's from Vesta. But you might say, how do we know that? We haven't sent any probes to Vesta. It's only very tiny. How do we know it's from Vesta? Well, if we look, you imagine if you've got a piece of meteorite and you shine light on it with different colours, all the way from infrared up through red to blue to ultraviolet, and measure how much light gets reflected in each of those particular colours. Different types of meteorites reflect different colours by different amounts. So you can see here this particular type, it goes up and down. The particular colours in the infrared, it doesn't reflect very much at all, and then it reflects more and then it drops off. So you get this particular, almost like a fingerprint of meteorites like this. Now we also know that light is coming from the sun. So if we measure the light that is reflected off these larger meteorites, and we measure what percentage is reflected of each of the colours of the light, we get a fingerprint of all the large asteroids that are out there. And you can see this one here, there's a very characteristic bumpy shape to it. And that's what Vesta looks like if you were to measure how much light of different colours are reflected. And if we put that same fingerprint that we got from those little pieces of meteorite over the top, this is the sort of fingerprint we get from that little stone here. And you can see it follows Vesta extremely well, and it doesn't look like any of the others at all. So we know that that little piece of stone is from Vesta because it has that fingerprint. So what happens in the impact? If you were to see one come through, you see as it gets hotter and hotter, pieces of it will melt and fall behind. It will leave behind a bit of a smoke trail. You can see the smoke trail there. You see little bits breaking off and falling behind. So it's breaking into individual rocks as it's falling through the air. Now they worked out the exact path of this. They came over America came right up into New York, and it hit this guy's car. He pumped his car, and when he came out, there's a great big hole in it, and a rock sitting just below the bumper. Now, before his car got hit by this meteorite, it was worth about $300. It was a pile of junk. He sold it 12 months later for $10,000 US, purely because it got hit by a meteorite right on the back. It's now owned by a meteorite collector, and the Peekskill meteorite actually has its own website. It has details about the meteorite, but also it has details of where the car's gone. It travels the world. It goes to various shows, astronomy shows, meteorite shows, crystals, all that sort of thing. And they ship it around. It's also been to Japan. It's been to Europe. And people, it hasn't been to Australia that I know of, but people line up there to, this is in Tokyo, to have their picture taken with the Peekskill car.
The one on the other side is Germany.
Yeah, that's in Munich. So it gets around. So what happens in the impact when the material actually hits the ground? Now, a good example is on the moon. Because there's no atmosphere, it's very clear, you can see. This particular crater here, called Tycho or Tycho, you can see there's been a large impact, and you will also see these lines of material that have been thrown out from the crater. Some of these, what they call a ray, some of them can go maybe halfway around the moon. So the material can travel a very long distance because there's no atmosphere to slow it. But most of the material comes up and falls back down again, and it creates the characteristic crater that you expect to see, like the one that we saw earlier in my talk. So how much energy does one of these meteorites have? Just a comparison of the types of explosives you might have laying around in a garage or something like that. TNT dynamite, nitroglycerin. Right? This is how much energy, don't worry about the numbers, but that's how much energy is in 1 gram of each of these explosives. If we get a meteorite that's relatively slow, 10 kilometres per second is quite slow. So that's 35,000 kilometres per hour. It has 17,000, right? So dynamite has just over 1,000. A slow meteorite has 17,000. If you get a more typical speed, 20 kilometres per second, 70,000 kilometres per hour, it has 70,000 calories per gram. So a meteorite at that speed has 60 times its weight in dynamite for energy. So you can see how a small rock can make a huge hole in the ground because it's much more powerful than dynamite or TNT or any of those.